Hello and welcome to today's class. With this class, we're going to discuss about the concept of application of differentiation, right? We have talked about the concept of differentiation. So I have provided a full tutorial course on differentiation alone. So we have tutorial course on differentiation, integration, right? For people that want to learn calculus. So I've done a video, a series of video for differentiation, right? So now we're going to be looking into the application of differentiation. How do we possibly apply differentiation in real life sense? All right, let's look at the application of differentiation. There are several applications of differentiation. So the first one they include rectilinear motion. So let's discuss this first concept for this class. We'll look into the concept of equation of tangent and normal in the next class. Let's look at the first one called rectilinear motion and look at what it means and how do we apply the concept of rectilinear motion in the concept of application of differentiation. All right, given distance at this point now, given distance slash displacement as a function of time, that is given distance slash displacement as a function of time, that is s of t. Given distance slash displacement as a function of time, that is s of t. Recall that at this point here, velocity is the rate of change of displacement or distance. At this point there, recall that velocity v is the rate of change of what? Displacement. That's the s over the t. I am saying that given distance slash displacement as a function of time, that is s of t, right? Recall that velocity v is the rate of change of what? Displacement. At this point, also recall that acceleration a is the rate of change of what? Velocity. Recall that acceleration is the rate of change of what? Velocity. So mathematically I'm having acceleration to be equal to what? Dv over what? Dt. So I can express the v over the t in terms of what? Dx squared over dt squared. So I have this Major's equation here. So I say that given distance slash displacement as a function of time, that is s of t, recall that velocity v is the rate of change of what? Displacement. Also recall that acceleration is the rate of change of what? Velocity, as you can see. So I can express acceleration in terms of what? The s squared over what there? The t squared. What do I possibly mean with all this concept? Let me explain. We say that x signifies distance or displacement. Mind you, when it comes to physics, these two are not the same. But by the way, we assume they are the same under this concept, please. So we say that x is what? Distance, or perhaps we call it what? The displacement. So we say that velocity, that is, we said velocity v, right, is what? The rate of change. That's what? D over dt. So velocity is the what? Rate of change of what? Of distance. So what's distance here? X. So rate of change of what? X. Multiply this. D times x is what? Dx all over the t. I have the t. That's why I have v as being equal to what? This over the t. Rate of change. D over the t is rate of change of what? Of distance. That's represent what? The velocity v. So at this point now, also we say that acceleration a is what? The rate of change of what? Of velocity, that is v. Combine these two, d times v is dv all over this times t, that becomes the dt, which is equal in value to, we said, what's v alone? So I'll have, look up, at this point, what's v alone? V alone is what? D over the t. So I'll have that d, this d, into what's v? That's ds over dt, all over what? dt. I'm here. Combine these two here. What do I get? I'll have that acceleration a is equal to, I'm trying to prove why acceleration is what? The s squared over the t squared. I'm trying to prove that to you. So from here, acceleration a now is equal to d times dx. That becomes d squared x all over. So it's d squared x, so please, not the s squared. D squared x all over the t squared. So I have the squared x there. Observe that I multiply d with the x. I have d squared x. Mind you, there's a dt left. I have dt, yeah. So divided by what? dt. I have dt. From here, I'll have the acceleration a is equal to d squared x all over dt times, there's an invisible one here. That becomes 1 over what? dt. What do I get from here? Ojo, show me now. Don't cancel it though. So multiply this. I have the squared x times 1. That gives the squared x all over dt times dt equals dt squared. This becomes how I got acceleration to be equal to the squared x over the t squared, right? So now listen up. The major task you need to understand when it comes to rectilinear motion is that if you are given distance, listen up, oh, if you are given distance, to get velocity, differentiate once. Listen up, please. I said if you are given distance, that is x, to get velocity v, differentiate once. To get acceleration a, differentiate twice. What do I mean? Look up. Let's assume that I have that y is equal to x to the power 4. Now listen up. This becomes what? A concept under what? Differentiation. So my first task, I have that the y over the x here is equal to what? 4s cubed. If I differentiate this one once, I'll have 4s cubed, right? This answer again, if I still differentiate this answer again, that becomes what? D squared y over the x squared. Why? Because I'm differentiating this one again. All I have here, I'll have 12s squared. So if I differentiate this answer, I'll have 12s squared. If I still proceed and differentiate this thing again, so if I differentiate this one again, I'll still have what? I'll have the cube y over the s cube. That will give what there? 24x. So the idea is that if I differentiate this one first, I'll have the y over the x. If I differentiate this one again, I'll have the squared y over the x squared. Divide this one again, I'll have the cube y over the s cube. If I divide this one again, I'll have what there? The d to the power 4y over what? The s to the power 4. This is how it works. So that is that. Let's assume now that this is distance. To get velocity, differentiate once this way. To get acceleration, depending on that answer, you have this one. So this is because of what I'm trying to say. So I'm saying that if you are given distance, to get velocity, differentiate once. To get acceleration, differentiate that thing twice. All right. With all this thing we have learned so far, let's look at how to solve problems under rectilinear motion and see what we get. Welcome back. Example 1 says the motion of a particle from O, open a bracket, origin, close the bracket, is described by the equation x is equal to 2 over 3 t cube minus 17 over 2 t squared plus 21 t. So I'm saying that the motion of a particle from O origin is described by the equation. I have this one here. So the question says when s is distance in meters and t is time in second. Mind you, when it comes to rectilinear motion, every single parameter, that is x or t, they will define it for you. So I'm saying that they're telling us that x here is what? Distance. Y t is what? Time in second. No problem. All right, we're saying as find A, number one there, the velocity and acceleration of the body after 2 seconds. Number two says the acceleration of the body of the particle when it's momentarily at rest. So let's get this done, please. When it's first, this becomes a distance equation. This becomes distance. So don't mind that. No, I said if I given distance to get velocity, differentiate this thing once. To get acceleration, differentiate this thing twice. That's the concept. So question A says what? Question A says the velocity and acceleration of the body. Question A says find the velocity and acceleration of the body after 2 seconds. So question A, I'm looking for velocity and acceleration of the body, but what the after 2 seconds? What's the concept? Let's find, my first task now is to get velocity first, then acceleration, because I can't look for acceleration straight. You must look for velocity first before what the acceleration. So let's start with for velocity equation, we know that v is equal to what? D over dt of x. That is v. We said that earlier that v is this, right? So if v is this, so it means that v now is equal to d over dt of what's x? X says everything here. That becomes 2 over 3 t cubed minus 17 over 2 t squared plus 21 t. So we said to get, if I'm given distance, s here is distance. If I'm given distance, to get velocity, differentiate one. So I'm going to differentiate the term in brackets here. I want that v is equal to differentiate 2 over 3 t cubed. What do I get? By the way, for those that have forgotten differentiation, I'll break this down as possible as I can, right? So let's break down this one. We said multiply the power. The power here is 3 times everything here is what? 2 over 3 t cubed. General method of differentiation. This becomes your general method of differentiation. Minus. We said the power comes first. Multiply by everything here is what? 17 over 2 t squared. So minus 1 for the power. Minus 1 for the power, please. We said write out the power and subtract 2 for the power. That becomes your general method idea. So the power here is 3. Everything here is this minus 1. Minus 2 is the power. Everything here is 17 over 2 t squared. Minus 1 from it. So plus my power here is 1 multiplied by 21 t to power 1 minus 1. All right, at this point now, what's v? Velocity equation v is now equal to 3 cancel 3. That becomes 2t squared. So I have 2t squared left here minus 2 cancel 2. That becomes 17t. I'll have 17t plus 1 times 21. That becomes 21. T raised to the power 0 is 1, right? 1 minus 1 is 0. N to the power 0 is 1. So I have 21 as my answer. This one becomes my what? Velocity equation. So I got velocity after differentiating this thing once. Now let's get acceleration equation. So let's get for acceleration equation for acceleration equation. We said to get acceleration, I'll differentiate twice. It means that I'll differentiate this one here and get acceleration. So mind you, said acceleration A is equal to what? D over the T of what? Of V. You said that earlier now, this man here. So from here, I will have that A is equal to D over the T of V. What's V? Everything here, that's 2T squared minus 70T plus 21. Differentiate this one, I'll have that A is equal to 4T minus 17. So my acceleration equation becomes 4T minus 17. My velocity equation becomes 2T squared minus 17T plus 21. But I'm not done yet. The question says find the velocity and acceleration of the body. This is here. But what? After 2 seconds. That's the concept now. So after 2 seconds becomes an idea now. So I have now. So from here now, I'll say that let's say, let me divide like this. Let me put my velocity here. V is equal to 2T squared minus 17T plus 21. And velocity equation. Acceleration is A is equal to what? 4T minus what? 17 as my acceleration equation. We said after 2 seconds. So at T equal to what? 2 seconds. What will be the velocity equation? So V now is equal to 2 into what's T? T is 2. So I have 2 all squared minus 17 into 2 plus 2. So V is equal to 2 into 2 squared gives 4 there. 4 minus 70 times 2 is what? 34. Am I right? 34 plus 2. This one, V is equal to 8 minus 34 plus 2. Please, what's my velocity equation? What's my velocity of the body after 2 seconds? The velocity of the body after 2 seconds will be equal in value to please, hang on, this one 21. Oh, 21 please, 21, not 2. So my answer becomes a negative 5 meter per second. So know that velocity is measured in what? Meter per second. So it becomes my velocity of the body after 2 seconds. Let's get acceleration of the body after 2 seconds. So at T equal to 2 seconds, what acceleration? That A is equal to 4 into what's T? T is 2. So minus what there? 17. From here, A now is equal to 8 minus 17. So my acceleration equation of the body after 2 seconds is equal in value to A is equal to minus 9 meter per second squared. So it becomes my answer to that question. So question A says find the velocity and acceleration of the body after 2 seconds. So therefore, the velocity of the body after 2 seconds is minus 5 meters per second, while the acceleration of the body after 2 seconds is given as minus 9 meters per second squared. So note that acceleration is measured in meter per second squared, while velocity is measured in meter per second. So it becomes my answer to question A. Question B, under question 1 says that what's it called? Find the acceleration of the body of the particle when it is momentarily at rest. So let's do B and let's see what we get. So still on question 1, but the part B. This part A. Let's do part B. Part B says find the acceleration of the particle when it's momentarily at rest. Here's the idea, please, for B. So yes, you are there. I'm looking for what? The acceleration of the body when it's momentarily at rest. Yes, I there. Listen up. When a body that its velocity, that is v, is equal to 0. So note that when a body is at rest, that its velocity is what? Its v is what? 0. So I'm trying to find the acceleration when the body is at rest. So the idea is that we know that acceleration a is equal to what? D over dt of what there? Of v. True or false? True. So for me to get acceleration, I need to know what? I need to know the value of v, right? So the idea now is simple. So since the body is moving at rest, so I say that v is equal to 0. What's my v equation? My v equation is this. So v is everything here. So we're saying that velocity v is equal to 0. Why? Because the condition is that the body is what? Momentarily at rest. So v now, what's v? V is 2t squared minus 17t plus 21. So equal to 0, 0. My v value is everything here. Equal to 0, equal to 0. So let's find v. So no, our task is to look for what's it called? Acceleration. But the condition there is that the body is at rest. So it means that velocity is 0. So we need to get what? Solve this one using what? The concept of quadratic equation. Solving this man here using quadratic equation, what do I get? Mind you, I will not start solving this one using quadratic equation. I'll just give you the answer to this one. I believe by now you should know how to solve problems under quadratic equation. Mind you, if you don't know how to solve problem under quadratic equation, I'll drop a link above you there. I'll take you to a video that will explain the concept of quadratic equation, right? So my answer here, if I solve this one correctly, my answer here becomes t is equal to 7 seconds or t is equal to 1.5. So my two values for t becomes these two answers, right? So now look at the question. The question says find the acceleration of the particle when it's what? When it's at rest, Abi. So we're looking for the acceleration of the body when it's momentarily at rest. So here's the condition which we have done, right? So I'm having t as 7, t as 1.5. So the task now is that find the acceleration. That's the major question there. So we know that acceleration a is equal to what? 4t minus what? 17. This becomes my acceleration equation. So I have gotten my value for t and t. So then I will have the two value for what? Acceleration. So now let's now look at the two value for acceleration. We said that let's consider at t equal to 7 seconds was acceleration. So a is equal to 4 into 7 minus 17. A is equal to, if I multiply 4 by what's it called? 7, I have what there? 28 minus what? 17. So a is equal in value to 11 meter per second squared. This at t equal to 7. Let's consider at t equal to 1.5. What do I get? A is equal to 4 into a equal to 4. What's your t in this case? 1.5 minus 17. A is equal to 4 times 1.5. That will give about 6. 17. A is equal to a negative 11 meter per second. So question B says find the acceleration of the body when it's momentarily at rest, Abi. So A is equal to 11 or minus 11 meter per second squared. Listen up. In between my left hand side and right hand side acceleration, which one is the real value for acceleration in this case? Of course, take a little bit to think. I'm having to value for acceleration. A is positive 11, A is negative 11. Which one is the real value for acceleration in this case? Of course, my real value for acceleration is what? Is a negative 11 meter per second squared. Why? Because the original acceleration, this one was what? A negative. So it means that the other acceleration I'll be getting must be what? A negative acceleration. So it becomes how to solve this particular problem under rectilinear motion. We'll look at the concept under application of differentiation in the next class. Down this with the equation of tangent and normal. So see you in the next class. Thanks for watching and welcome to Excellent Academy. If you are interested in assisting us within the assistance, right? So if you're interested in assisting us, do well to reach out to me with my WhatsApp number, right? And we can accept donations, right? So to further improve our academic activities. So thank you. Welcome to Excellence Link Academy once again. See you in the next class. Goodbye.